Okay, hi guys. Welcome to the OneClass channel. My name is Sydney and I'm currently a third-year engineering student at university. So today we'll be going over some popular commonly asked math questions at both the high school and college level. So if you need some additional help after this or some tutoring, please check out the links in the description below. And let's get started with the questions. Okay. So the first question we're looking at here is asking, what is a multiple of a number? So I'm just going to be walking you through the solution here, as you can see. So it says that a multiple of a number is any number reached from multiplying a given number by another. Now that might sound a little bit confusing, so I'm going to write it as an equation here. So we can say that it is something like this. So B equals n times A, where A is just your arbitrary number, n is an integer, and then B, therefore, is the multiple. Okay? So a multiple is just that, just a number times an integer, and then the product is a multiple. So it gives an example here. Really simple one of just 2. So multiples of 2 can be seen as 2, 4, 6, 8, and I think you get the idea. So 2 is just the product of 2 times 1, the integer being 1. 4 is just 2 times 2, you know how it goes. Of course, you can go beyond that, you can have 20, and it also states here that the integer could be a negative number, so if you have 2 times negative 10, for example. So it says that the multiplication table is a good example of showing multiples of numbers, and I can say that this is true. So it also goes a little bit into saying that a common multiple is something we can look at too. So if we have 2 different numbers, for example, we can have 6 and 8, 6 and 8, and look at those, the multiples of those numbers. So for 6, you can have 6, 12, 18, 24, etc., etc. For 8, you could have 8, 16, 24, 32, and you know the pattern. And a common multiple here, you can see that the number 24 shows up for both of them. So that's a common multiple, or a multiple that they have in common. So in this case, it also happens to be the lowest common multiple. So I'm sure if you keep looking at multiples of 6 and multiples of 8, they'll have another multiple in common, but this one is the lowest that we can find. So I'll just keep reading the solution here. So for example, a common multiple of 6 and 8 is 24. Yes, we know that 6 times 4 is 24 and 8 times 3 is 24. So it's not the only common multiple, but it is the smallest, as I said. They also give a couple other examples here of multiples of 3, multiples of 4, multiples of 6, and as you can see between them, the I'm just going to draw a line around it. The lowest common multiple there is just 12. Of course, they also have 24 in common, but 12 is the lowest, so it's the LCM, or lowest common multiple. So another way to find a lowest common multiple is to use factorization. So you can take the number 12 and divide it by integers to get factors such as 1, 2, 3, 4, 6, 12. So since 3, 4, and 6 are factors of 12, that makes 12 a common multiple. So we can see that the solution is correct, so I'm going to move on to the next question. Okay, next question that we have here is asking us to use a cylindrical shell or cylindrical shells to find the volume V of the solid sphere of radius r. Okay, so we're going to start by picturing this. I like to picture it kind of as, say, like an orange, okay? So that's a solid sphere. I'm going to take this sphere and draw the coordinates of it. So we have y-axis and x-axis. And if we imagine this as a 3D sphere, like I said, like an orange, we can then imagine we're taking a slice out of this orange, okay? So imagine taking your orange and slicing it up like this, along the y-axis, okay? So looking at it, here, I'll just redraw this part a little bit. So looking at this one specific slice, we're going to call this a disc, okay? A disc, or we can imagine it as a cylinder. It has a thickness, which is very small, that we're going to call dx. Okay? Just lower this a little bit here. Okay, so we can imagine it sort of from the side view as well, looking at it from the side, coming from the x direction, and it just looks like a simple circle, okay? And on the y-axis, and it has a height of y. Okay, I'll draw it on here too. It has a height of y. And this, here I'll use a different color instead. This, maybe something that's easier to see. Okay, so this slice is going to be about x distance from the center. It's going to have radius r, and it's going to have a height of y, a height just from the x-axis, okay? So as you can see, this kind of creates a triangle made with these green lines, right? So we know that radius is equal to y squared plus x squared, and we're just going to rearrange that to find that y squared equals the square root of r squared minus x squared, and you'll see why later. Something that I didn't label here that we also know is that this orange has a radius of r. So from the center to the outside is radius r. If we're going in the other direction, to the other side of the orange, we can say that the radius is minus r, since we're using this axis. Okay? Just making sure you can see clearly here. Okay, so let's start with looking at this singular disk. We know that the volume of a cylinder is V equals the area times a thickness, okay? And we also know that the area is equal to pi r squared. I don't want you to confuse that r with the r that we're talking about here. In our case, we're going to think of this a little bit differently, okay? So we're thinking of the orange with a bunch of different slices that the slices are like mini discs, okay? When you add up all the slices, the volume of each slice, you get the full volume of your orange or your sphere, right? So that's what we're going to do here. We're going to use the integral sort of like a summation of all the individual volumes of all the disks. So hopefully that makes sense. So we'll start with dV, so that's the volume of the disk, is equal to the area or the surface area, you can see over here, of the disk times the thickness, which we stated before as dx, okay? As I've said before, the area is equal to pi r squared, And in this case, you can see that the radius is in fact y, because that's what we said is the height of your circle. So it's pi y squared dx. Now what we're going to do is we're going to take the integral. So the integral on that side doesn't necessarily have to be specified, since the only thing that we have there is dv. On the other side, however, we're going to say that the integral is taken from x equals to r to x equals to minus r. So looking back at our diagram here, that makes sense, because we are going to be going from the r on this side of the orange or the sphere to this side. So that's r along the x-axis to negative r on the other side. And everything, remains the same as it did before. Okay, so now we are able to start integrating. However, the first thing that I want to do is, well, since we are looking at this sphere, it should be symmetrical on both sides, right? So from r to the center of the sphere should be the exact same as from the center of the sphere to negative r minus r, okay? So it's like saying you're cutting this orange in half, and the volume of one half is the same as the volume of the other, right? So what we can do when an integral is symmetrical like this is we can, not a very good circle, take just half the volume and then multiply it by 2. So I'm going to take, also at the same time, just take this pi outside the integral, since we don't need to evaluate it, and then change the integral from r to minus r to r to 0. Can look at it like this. We have x equals 0, x equals r, and we're only going to take the volume of this and then just times by 2 to get the volume of that. So hopefully that makes sense. Just remove that for confusion, just in case. And then, so what we have inside that we can now evaluate is the y dx, y squared dx. And also the integral of dv is just b. Okay, so what we can do here, remember we wrote y differently here, right? So in fact, I didn't really even need to take the square root. If you rearrange it like this, you get y squared equals r squared minus x squared. So we're just going to substitute that into our equation so that we can evaluate this in regards to x. Okay? So 2 pi of integral of r to 0, and then replacing this y squared with what we came up with up here. Hopefully I'm not blocking that. So, r squared minus x squared and dx. Alright, so now we're on to integration. So, I'm going to be just using a couple of integration rules that probably came up or have learned before, right? Some things that you usually just have to memorize. So we're starting with r squared. So the integral of r squared, well, since it's with respect to x, actually we can, well, I'm just going to separate it so that you can look at these two separately, okay? So this is the same as this, r squared minus the integral, running out of room here, x squared. Oh, sorry, I missed the dx's in here. Dx, there we go. Okay, so yeah, now you can look at them individually in case that's more clear for you. Okay, so like I said before, we're gonna go through this first part. So the integral of r squared with respect to x, well, there isn't one because r isn't, there is no x in that formula, okay? So we can just remove that, and we have r to 0 of dx. And I'm just going to keep this the same, dx. Okay, next up. Now, dx integrated is just x, but we can't forget to evaluate it from r to 0, right? So that will be in the next step. And then we have the integral of x squared dx. So this is probably something that you either know or you can look up, and then you have to memorize this for future knowledge. So we'll just have x cubed over 3, and if you don't trust me, you can always check by taking the derivative and figuring out yourself that you should get x squared, okay? Remember, next up we're evaluating from r to 0, right? 2 pi. Okay, so r squared times, so we're evaluating from r to 0, so we're going to replace the x with r first, so on top is what you do first, r minus, and then the second one, replacing x with 0. Alright, remember that before we said that this was equal to x, so replacing the x's with r and 0. And then subtracting this second half here, so replacing the x, with r, minus 0. Well, I don't even need to write that because you know that's just 0, right? Pi. That's just 0, so we get r cubed minus r cubed over 3. Alright, now we can think of this as 3 over 3 instead of 1. And then you'll get, it's just subtraction here. So 2 over 3 r cubed. And finally, 2 times, I was going to say 2 times 4. 2 times 2 is 4 pi over 3 r cubed. And this is our final solution. Now you probably already recognize this as the volume of a circle, so we know we did well, right? So I did this differently, a little bit differently than the solution here, just because this is the way that makes sense to me, especially using the imagery of taking orange slices. So if we look at the solution here, they kind of go about it a little bit different. But ultimately we get the same answer, and there are a few more steps that they include. Like I said, here we get the volume of a whole sphere, and comparing to ours, we have the same thing, okay? So I'm just going to say correct. Good job. And we're going to move on to the last question. Alright, a little bit shorter than the last one. But the question is asking, what is the derivative of ln x squared? Okay, so to do this, we're just going to look at a couple of, once again, formulas or or things I guess you should already know. You should probably, you're probably going to need to memorize, or since this is online school, maybe just have written down somewhere, right? So let's start by writing down the question. So what do we know here? Well, we probably know, I'm just going to say, so you know that this is something that should be memorized. Well, we have our lawn laws, and the one that we can use here is the power rule. So that lawn law states that if you have a lawn xy, you can basically take out this power, or the exponent, and put it out in front and multiply the lawn by it, okay? And then something else that we need to know is what the derivative of lawn is. And this is just equal to 1 over x, okay? So using this known information, I'm sure you can probably see where we're going with this, right? So d of x, or the derivative of ln x squared with respect to x, we'll take that 2 out first, dx ln x, right? And then we just did this right above, so we know that from that we get 1 over x. So our final solution is 2 over x. Look at that, I was quick. Okay, so looking through the solution here, we see that they do the same steps. Take the 2 out first as the exponent. Make sure that you know that the derivative of ln x is 1 over x, and then you get 2 over x. All right. Good work. Oh, I can't type apparently. Correct solution. Ooh, there we go. It's kind of hard when things are in the way, but looks good. All right. So that's all I'm going to do today, just the 3 questions for now. If you found this helpful, please leave a like, and if you want to be notified of us doing another Q&A, please hit the subscribe button and the notification. If you'd like to submit some more questions, your own questions, you can see the links in the description, or you can just leave them down below. And I just want to wish you good luck studying. Thanks for watching. Bye.